Right now, tonight, a volcanic dome is steaming at 89 degrees Celsius on the south face of Mount Hood. That is nearly boiling. The gas cracking out of its fissures has been measured at above 300 degrees Celsius. That is a magmatic signature. That means there is still hot rock down there, still breathing. And 200,000 Oregonians are living directly in its path. They just don't know it. Here is the number that changes everything. In 1997, 7 scientists at the United States Geological Survey published Open File Report 9789. 7 authors: Scott, Pearson, Schilling, Costa, Gardner, Valence, Major. Inside that report is one sentence that has haunted volcanologists ever since. One sentence that Oregon's emergency planners have never fully acted on. One sentence that no politician in Salem has stood up and read aloud in public. The probability of eruption-generated lahars affecting the Sandy and White River valleys is 1 in 15 to 1 in 30 during the next 30 years. Read that again. 1 in 15. That is a 6.7% annual probability at the high end. Roll a single 6-sided die. If it lands on 1, the lahar has come. Every year. For 30 years. No other Cascade volcano carries a near-term lahar probability this high. Not Rainier, not Baker, not Glacier Peak. Hood is the youngest. Hood is the most loaded. Hood is the one geologists speak about carefully. And there is one word they speak most carefully of all. Lahar. A lahar is not lava. It does not glow orange. It does not move slowly enough for you to walk away. A lahar is a river of concrete. Wet volcanic ash, pulverized rock, melted glacier, ripped up forest, moving at freeway speed. Down a river valley. It does not warn. It sounds like a freight train. And it arrives like one. To understand what Mount Hood is really holding, you have to look up. At 11,249 feet, Mount Hood wears 12 named glaciers and snowfields. Palmer, Reed, Zigzag, Sandy, White River, Elliott, Coe, a crown of ice, sitting directly above communities of tens of thousands of people, directly above the drinking water supply of 1 million Oregonians, directly above Interstate 84, directly above the Union Pacific Main Line, and directly above a 40-mile-long death corridor that the state of Oregon has never built a single warning siren to protect. But here is the detail that tells the real story. Just below Mount Hood's summit, at roughly 9,800 feet, sits a feature called Crater Rock. Most people who see it think it's just a rocky outcropping. It is not. Crater Rock is a solidified lava dome, a plug of extruded magma that forced its way to the surface sometime between 1781 and 1793. The eruption geologists call the Old Maid. Today, the fumaroles at its surface measure 89 degrees Celsius. Near boiling. The gas escaping through its cracks, analyzed by geothermometer, registers above 300 degrees Celsius. That is not a cold, dead volcano. That is a sleeping one, with heat still moving beneath it. And beneath the steaming dome, the mountain is rotting. Hydrothermal alteration. The volcanic system has spent 2 centuries chemically dissolving its own rock from the inside, hot acidic fluids eating through the summit, converting solid dacite into clay. Altered rock is roughly 10 times weaker than fresh rock. The upper flanks of Mount Hood are held together by material that, in structural terms, is barely holding at all. Here is what the scientists have modeled. Magma pushes up. Pressure builds. A new dome grows on or beside crater rock. The weakened acid-cooked rock gives way. Pyroclastic flows race down the flanks, at hurricane speed. Those flows cross 12 glaciers in seconds. They flash melt the ice. Within 10 minutes, a wall of volcanic concrete is moving down the Zigzag River. Not in the future. 10 minutes from the moment the dome collapses. Within 30 minutes, that wall has overwhelmed government camp. Rhododendron. Communities with a combined population of nearly 13,000 people. Within 90 minutes, the Lahar reaches Troutdale on the Columbia River, a town of 6,500 people, built on a river delta. That is not a river deposit. That is a Lahar deposit. From the last time, this mountain did exactly what the models say it will do again. This is not a worst-case scenario. This is the modeled case. And this is where history enters the room. On November 3, 1805, William Clark walked to the mouth of an unnamed river flowing into the Columbia from the south. He tried to wade it. He wrote in his journal that he was astonished. He could not cross. The bottom was quicksand, impassable. He described a wide braided channel, an island of coarse sand 3 miles long, and water running brown and fast. The expedition named it the Quicksand River. Modern Oregonians shortened it. Today we call it the Sandy. 5 months later, in April 1806, Sergeant Nathaniel Pryor went upstream to scout it. He reported the riverbed was formed entirely of quicksand, that a pole could be driven 6 to 8 feet in with no solid bottom underneath. Here is what Lewis and Clark did not know. The old-made eruption of Mount Hood had ended roughly 10 to 20 years before they arrived. Tree ring dating places it between 1781 and 1793. The expedition was standing in the freshest Lahar deposit in North American history. The quicksand was not sand. It was fluidized volcanic ash and pulverized dacite, still flushing down the valley 2 decades after the eruption that made it. When Lewis and Clark named the Sandy River quicksand, they were not describing a river. They were describing a crime scene, and the killer is still on the mountain. Which is why what happened on June 5, 2021 got the attention of every volcanologist in the Pacific Northwest. That morning, a magnitude 3.9 earthquake struck 2.5 miles south of Mount Hood's summit. Depth, 2.7 miles. It came with 4 foreshocks. It came with an aftershock sequence. And it followed a swarm of over 100 earthquakes in January 2021, and a 45-minute swarm in March. Dr. Wes Thelen, geophysicist at the USGS Cascades Volcano Observatory, analyzed the swarm. He confirmed it had all the characteristics of a tectonic swarm. No magma movement, no ground inflation, good news. But catch what else he said. Scientists could only say that with confidence because 9 months earlier, USGS crews had installed 3 new monitoring stations on the mountain. Seismic, GPS, gas sensors, 9 months earlier. That was the margin between knowing and guessing on Mount Hood. 9 months. If those stations had not gone up in 2020, the June 2021 swarm would have been a mystery. Dr. Allison Colser at Oregon State University explained to Oregon Public Broadcasting what the next eruption will most likely look like. She said most of Hood's eruptions over the past 30,000 years have occurred in roughly the same way. Lava oozes up, forms a lava dome, a blister of lava near the top of the volcano. Her word, blister. A blister at 9,800 feet. Sitting directly above 12 loaded glaciers, directly above the headwaters of the Sandy and Zigzag rivers, directly above Timberline Lodge. And this is where it gets personal. Timberline Lodge sits at 5,960 feet on the south flank of Mount Hood. It was built between 1936 and 1938 by Works Progress Administration craftsmen during the Great Depression. On September 28, 1937, President Franklin Roosevelt stood on its terrace and dedicated it a National Historic Landmark. $350 a night for a standard room. The lobby window looks straight up at Crater Rock, less than 3 miles away. Still fuming, still steaming, still exhaling at 89 degrees Celsius. The USGS has mapped exactly what sits beneath the lodge's foundation. Much of the broad fan below the south flank, including beneath Timberline Lodge itself, is underlain by pyroclastic flow and Lahar deposits from the last eruption. Tourists pay $350 a night to sleep on a tombstone, beneath the WPA-era timber floors, beneath the hand-carved pioneer motifs, beneath the stone hearth laid in 1937, beneath the old-growth beams, is compacted volcanic debris from the last time this mountain did what it does. A guest sits by the fire, orders an Oregon Pinot Noir, looks through the lobby window at a steaming dacite dome 3 miles up the flank, and has no idea the entire lodge is parked on the last eruption's receipt. Now widen the lens. The strict 500-year hazard zone published in Oregon's Dogami Bulletin 01116 places roughly 5,000 people in direct proximal risk, but that is the narrow number. The full downstream corridor tells a different story. Count the Sandy River Valley, count the zigzag drainage, count eastern Gresham, population 116,000, count Troutdale, population 16,500, built on a Lahar Delta. Count the Interstate 84 interchange at the Sandy River mouth. Count the Union Pacific Main Line running beside it. The full downstream totality approaches 200,000 Oregonians. 200,000 people. Living in the shadow of a mountain with a 1 in 15 Lahar probability in the next 30 years. Without a single warning siren system. Without a dedicated evacuation route plan. without a public alert protocol that anyone has ever tested. And it is not just people at risk. Portland's primary drinking water comes from the Bull Run watershed. 1 million people drink from it. The watershed itself sits behind a geographic ridge that offers some protection. But the pipelines that carry that water into Portland cross the Sandy River corridor directly. A Lahar that reaches the Sandy River mouth severs those pipelines. On the same afternoon, 1 million people lose drinking water by dinner time. Dogami has counted up everything in the study region, 47,000 buildings inventoried, 104 schools and emergency response facilities, 1,600 miles of road, 340 bridges, 944 electric transmission towers, 615 miles of transmission lines. 20% of highway miles in Hood River County sit inside debris flow hazard zones, and Bonneville Dam sits 25 miles downstream of the Sandy-Columbia confluence, the largest hydroelectric dam in the Pacific Northwest, directly in the path of a debris flood arriving from upstream. Here is the detail that should make every Oregon official uncomfortable. In 1980, a small debris flow on Palali Creek caused $13 million in damage and killed one person. Not an eruption, not a volcanic event, just rainfall. Heavy rain on loose volcanic sediment on the east flank of Mount Hood. That was a drizzle, a fraction of what the modeled Lahar scenario produces, and it destroyed 5 miles of highway, 3 bridges, and a state park in one afternoon. Now let the full numbers land. 1 in 15 probability, 11,549 feet, 12 loaded glaciers, 89 degrees Celsius at Crater Rock, 300 degrees Celsius in the escaping gas, 1 million Bull Run drinkers, 47,000 buildings, 104 schools, 340 bridges, 200,000 people downstream, 50 miles to downtown Portland. So ask yourself 3 questions. How does a mountain with a 1 in 15 probability of a valley-filling Lahar in the next 30 years sit at alert level normal? How does a national historic landmark, built by Depression-era craftsmen, dedicated by a president, and parked directly on pyroclastic flow debris, advertise itself as a romantic getaway without a single geological disclosure? And how does a river that William Clark literally could not wade across in 1805, because it was still choked with ash from an eruption that had ended less than 2 decades before, get its name softened to sandy and forgotten by every community built on its banks? The die is still on the table. The faces still number 1 through 6. Crater Rock is still steaming at 89 degrees tonight. 12 glaciers are still loaded above it. The Sandy River is still running brown through Troutdale every spring melt, carrying, grain by grain, the last of the old maid eruption down to the Columbia. And Lewis and Clark's warning, written in iron gall ink in November 1805, is still true. The bottom is quicksand. The bottom is impassable. The bottom is still coming down the mountain. The only question that Oregon has never answered is this. When the die finally lands on one, how many of the 200,000 people living in its path will have had any warning at all?